All right, folks, so for your second lab in simple harmonic motion, you're going to do 2 labs, but you're only going to write up one of them. So it's a pretty lab-heavy unit. It lends itself to it. So here are your choices for the second lab. You are going to, again, do both of them just so you get the experience thinking about these things, but you only have to write up one of them. So you can decide that ahead of time, or you can do them really informally and then decide. So, first lab, what is the relationship between the mass oscillating on a spring and the period of oscillation? Said another way, your task is to determine the proportionality between the period of oscillation of a spring and the mass that is used to oscillate it. For this lab, your spring has to be oriented vertically because none of us are in possession of perfectly frictionless surfaces that things can slide on. So having it just hang from something is ideal. Again, people at home, you have 2 different masses. You have a spring and hopefully a measuring device, so you can do this one no problem. You just need to hang your spring from something sturdy. There is these springs have, it's kind of like a keychain, right? This little loop at the end. You can separate that very gently from the rest of the spring. You can't really see that anyway. To fit it over something. So you can hang it from something else, or you can hang it from something that's going to hang from something else. You can be pretty creative about that. When you do this, again, you're collecting data on period and mass. Masses should be, it doesn't matter. Masses can be in anything because it's just a proportionality. So if you have a postage scale that measures in ounces, you could do everything in ounces. But grams is awesome because the masses that I sent home have grams written on them. So again, you can be creative and you can find other objects if you want to add data points to, if you have a way to find their mass. If you are very clever with or very careful with your Hooke's Law lab from before, you can actually weigh any object using your spring. Anyway, so you're finding the proportionality. The only way that I want you to do that is, again, to make a graph. Obviously, period is one of them. One of the things you want to graph, and mass is the other. And so determine the proportionality. The 6 options that you should consider are on the board. That period is proportional to mass, the inverse of mass, mass squared, the inverse of mass squared, the square root of mass, and the inverse square root of mass. So those are the ones I want you to consider. One of the true answers is up there. You can easily look up the equation for period of a spring if you want to know the answer right away. Cheaters, but you're not cheaters. But you, can get your way through that. So you definitely want to make a graph, and you don't need to do any really careful analysis because, especially people at home, you only have at least 3 data points, and that's not a lot to get the proportionality. So don't be too meticulous with the data analysis for either of these labs, but do try and determine the shape of the graph. And then the second option, what factors affect the period of a pendulum? And so there are 3, there's really there's not much that you can change about a spring, and there's not much that I'm telling you can change about a spring. But for pendulums, you can change the mass that's hanging from the pendulum, you can change the length of the pendulum, and you can change the amplitude. So mass is pretty easy, just change the thing that's hanging from the bottom. Length is also kind of easy. You can tie the string in clever ways so that it's a different length each time. Measure the length, and there you go. Amplitude is kind of tricky, but I think you can do it. What I would recommend is, let's say you hang your pendulum from something, and let me see if I can show it. Let's say you hang your pendulum from something. There we go. Hey, you can see that. And there's your mass. If you hang something else at the same time from the same hook or item, then you can get an equilibrium location right there. And then amplitude can be measured in centimeters. So maybe here's a 5 centimeter amplitude. Here's a 10 centimeter amplitude. You don't want to go too extreme because you actually start to get different results if you get to too big of an amplitude. So This is one way to do it, just by measuring like how far the pendulum is from the vertical. If you happen to have a protractor and think that you can do a good job measuring angle, you can measure angle using that. So, hold the protractor up here and then pull this to a certain angle and then let go and start collecting data. My biggest instruction for this lab is when you go to measure period, because you have to do it for both. When you go to measure period, measure 10 periods consecutively with the same time, and then divide by 10. That came out really strangely. Measure 10 periods and divide that by 10 to get the actual period. It sounds silly, but it will increase the accuracy of your lab by the factor of 10, which is exactly why you do it. If I thought that your masses could oscillate 100 times reliably, I would say measure 100 periods and divide by 100. But measure 10 oscillations, divide that time by 10 to get the period, and that will be your data that you take. For this lab, there's 3 things you have to analyze. And so mass, length, and amplitude, that's essentially 3 miniature experiments. And I really actually, let's get rid of that. Don't determine the proportionality, because I think enough of this lab will be which of these factors influence the period of a pendulum. And the secret is some of these might not. There might be 1 or 2 of these that don't influence the period of a pendulum. And so I want you to find that. Another reason why you're measuring 10 periods and dividing by 10 is because within your reaction time and margin of error, you will actually probably find out that all of these influence it because of the inconsistency of your own data. You might see things that aren't there. By measuring 10 periods and then dividing by 10, the 1 or 2 things that do influence the period of the pendulum will show up a lot better. And so once you get all of your data, make the determination of which ones influence it. Same deal, purpose, materials, procedure, data table, analysis, which would be a graph for both of them, and then conclusion. A conclusion, again, like what physics, conclusion would be mostly pretty straightforward, like what's the proportionality, and really not much to that. I will probably give you some specific instructions about conclusion when we're doing these in class, but that's at least enough to get started. Thanks.